Hello, everybody, and welcome to the show. My name is Nick Larson. Happy Thursday. Today is August 8th, 2019. It's about 12:01 in the afternoon. Just a moment late, but let's get started. First off, I'd like to give a shout out to Meito04, CM Griffin, and Nimolo00 for the follows yesterday. I really appreciate that. Also, CM Griffin for giving me the raid. Really appreciate that as well. It was awesome. We got started. All right. Let's get back to what we were doing. So we're working on a programming competition. This programming competition is the Reversing Nearness programming competition from Al Zimmerman's programming contest, which is currently active and doesn't end until October 26, 2019. So plenty of time to make improvements. And having participated in a number of his programming contests before, improvements will be made until the last few moments of the competition. So lots of time. Let's talk about what we did yesterday. Yesterday, we just got started from like having zero to having something. And what we did was basically make a program that could create the board, that could then populate the board, and then could start swapping pieces. Actually, we came up with a baseline for getting the scores, like the highest possible score, and then there's a lower bound as well, which is given to you on the site as part of the description. Let me bring that up because that's actually going to play a role today. So these are the lower bounds that are given to you. I don't actually know how these are calculated, but I thought of an idea about how they might be calculated yesterday, which might lead us to a solution, or to not to a solution per se, but to some ideas about how we can actually improve this. So that's sort of where we got to yesterday. We did a really greedy approach, which was you just create a random board, and then you swap elements. Or you look at all of the neighbors, which is swapping each possible pair of elements, taking the best one of those in terms of score, and then making that the board. And when you get to the point where there are no more improvements, then you just randomize it and restart, right? And that's the whole concept behind like a hill climbing algorithm with a random restart. Right? You're standing here, you look at all of the space around you, you say, that's the highest place. I want to climb the hill the fastest, so I'm going to go to the highest place. It's a very greedy approach, and you walk straight up there. When you get to there, you do the same thing. You look all around, you say, show me the next highest place. I'm going to go this direction now, and that's the highest place. And eventually, you get to the top of whatever hill that you're on, and you can't get any higher because everything around you is lower. So instead, what you do is you just say, randomly put me somewhere out on the board. In the space of all possible places that we can be, just randomize where I'm at, and let's see where we can go from there. And then you just do the same thing over and over and over. This is very related to another technique called simulated annealing. Simulated annealing comes with some guarantees, but conceptually, this is it. These are the same. That's kind of it. That's what we got through yesterday. I let this run overnight. When we got off the call yesterday, when we got off the stream yesterday, our overall score was about 8 point something. I let this run overnight. When it ran overnight, it ran half the night until midnight. Well, I guess a little later than midnight. Maybe it was like 2 in the morning. It ran on the values of 6 through, 18 or something like that. And then the second half of the night, it switched and it started running on the problems of 16 to 30. So we've made some improvements on each of them. In fact, we have found, if we go take a look at this, and we take a look at this, we have found the best scores that have been found for the 6x6 board, the 7x7 board. Right here you can see the score, and the score that is the best in the entire competition so far. And for the 8, we also found it for the 8. right? 57152. However, when we get to 9, we see that we do not have the best score yet. So one thing that I'm going to do, I am going to kick this off to run while we're streaming, and hopefully while we're streaming, it finds the best score for this. The reason I like going about things one of these problems at a time is that it lets me like stop worrying about that problem for the time being. Now at some point, probably around here, or maybe here, these are no longer optimal. Like these might all be the best possible scores that people will ever find because they just are the best possible scores, but almost certainly all of these are not the best possible scores and can still be improved upon. All right. So we're going to kick this off just so that it's actually doing some work. And then we are going to completely change directions and go a totally different direction as far as how we want to... Gonna go a totally different direction to see if we can come up with a way to find better solutions faster. And that's the goal for today. So let me get this kicked off. As soon as I get this kicked off, that was it, finding the best solution to 7. Let's go to the start. And let's say we want to find the best solution for 9. We're going to run this on 8 threads, because on my machine, pretty well taxed at the moment because I'm streaming. Let's just see what happens when I kick this off. If it gets too bad, if there starts being a delay or something like that, then we're just going to have to dial this back. But we'll see. I tried this when I was doing my work earlier, and it seemed just fine. So we'll see. All right, and you can see it's starting to hit half my threads pretty hard. Maybe I ought to do this on 7. I'm not entirely sure. All right, if things start screwing up with the video, just let me know or anything like that. And we'll, in the meantime, just sort of keep this grinding over here on the side. That's kind of hard to read. Just make it smaller, I guess. Bloop, 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 bloop. There we go. Okay. Let's come over here. All right, so the concept, what do we want to do today? Right now, what it's doing... Right now, what it's doing is starting... Okay. Right now we have a greedy best. Okay, so I want to figure out how these baselines are calculated, and I sort of have an idea. I think what they're doing is they're taking the initial grids and then they are ordering them by the distances to each of the elements. Like it's getting all of the distances, then it's ordering the distances, then it reverses the distances and says, if I match the biggest one to the smallest one and the smallest one to the biggest one, then I will minimize my score as a lower bound. Whether that's actually possible or not, because of the configuration requirements of the actual space that we have to configure these things in, is not entirely clear. But I think that's how they're coming up with these. And if that's true, then we're going to see if we can take advantage of that to change our greedy evaluation function from looking at the score to looking at how close we are to this idea of matching the highs to the lows. And we're going to generate boards from nothing. We're going to add one cell at a time. We're going to place one value at a time into the grid. And we're going to calculate the score of all the possible places that we could put that one piece. No. Yeah. I don't know. We're going to do something where we build out the grid instead of just swapping things around. That's the idea. Okay. So first, let's verify that these lower bounds, that's how they're actually calculated. The way that we're going to do that is we're going to say baseline. We're going to say something like, okay, check lower bounds or compute lower bounds. Static void compute lower bounds. And then for this, we're basically just going to say for int I equals 6. Well, really, int I equals 2. I less than 31. I plus plus. Oh my. Grid equals new grid of, we're just going to call this size. Now I want to know what the refactor button is. Rename symbol. Oh, there we go. Hey, alright. Size. And then we're going to say grid dot get distances. And then we're going to say array dot sort dist. Does that just sort it in place? It appears to just sort it in place. And then we're going to say var dist reverse equals dist dot reverse. And then we're going to say var lower bound equals dot of dist and dist reverse. And then we're going dot to array. And then we're going to say log lower bound of size is lower bound. Lower bound? Whatever. Okay. And then we're just going to return. This is just to check if this is actually doing this. Oh, .NET run. Okay. All right, we got a 10, a 72, an 816, a 3800. Yeah, this is okay. So this is how the lower bounds are being calculated, which is great. Which is great. Now all we need to do is take advantage of that somehow. How are we going to do that? I think maybe, what if we, we want to build the board, so we want to get all of the elements of the board, and then we want to place them, and the evaluation for which one we choose comes down to what? Sort of spacing out a little bit. Okay. Okay. How are we going to do this? I'm going to say something like static void build up. And this is just a concept. Int size. And same concept here. We're going to have random restarts. Okay. So in order to do this, we are going to want to let's just do one. Build a grid, var grid equals new grid size. I feel pretty flustered today a little bit. I don't know what it is. My brain is like not focused on this thing right now. It's focused on something else. I don't actually know what it is. It just can't really seem to focus on this. So we have a grid, and we now want to be able to place items onto it. Right now we don't really support that per se. Let's go take a look and see if we found... Oh, look, we did find improvements. Let's go see. Did we find the best one? 14.4.4.59. 144.459. That's what we're looking for. Okay. So we're not going to worry about that until we actually reach the best one, because it'll keep finding new ones. The grid does not support directly editing the cell values. So instead of creating a grid here, let's create an array. And cells equal new int of size times size. Right, it's a square grid. All right. Now what we need is for int I equals 1, I less than cells dot length, I plus plus, cells of I equals -1. So this is my way of saying that we have not filled this cell yet. We have not filled this cell yet, and we need to. I'm struggling. Okay, let's solve this without code first. So I have a grid and I want to place a new thing into it. That's super simple to do. I look at each possible grid location and I look at each possible value that can go in there. And then looking over all of those, I end up with, I need to score them in some way so that I can then choose which one to do next. All right, so how do I score them? So the way that I score them is I create another grid yeah. So I take the distances. All right, so I'm trying to take the far distances and put them close together. And the way that I evaluate that is I want to focus on turning the highest values into the lowest values, and then with a lower priority worry about the other things. So what I'm going to do is I'm going to take all of the distances and all of the distances, I'm going to subtract them from one another. I'm going to square them element-wise. And then I'm going to sum them together, and I'm going to take the highest score. Because the highest score gets me as close as possible to the optimal ordering. Yeah, I think so. Okay, so let's create the score function. Static long build up score. This takes long array. Is it int or long? The distances aren't going to be long. Int array A, int array B. So these are our distances, and I am going to say bar total equals long total equals 0L. Then I'm going to say for int I equals 0, I less than a dot length, I plus plus, total, no, diff equals math.abs of a sub I minus b sub I. That gives me the total difference, and then I want to say total plus equals diff times diff. So I take the difference of them, the absolute value. Well, I don't even need to take the absolute value because squaring them will take care of that for me. So I take the difference of them, I square the difference, and I add it to the total, and that's the score. Okay, so now I have my grid set to all -1s with the exception of the first element, which I always want to be AA. So now I'm starting to think that I don't want to do it like this. Starting to think I want to update my grid a little bit. So I've already got a lot of logic in here. We'll come back to that. Okay. So I need the original cells, the original distances. Okay. So we say var baseline dist equals new grid of size dot get distances. Alright, so I have the baseline distances. Then, for each I'm just going to make this baseline distances like something I can look up because I use it so often. Like I'm pretty sure I use it in here. Yeah, baseline distances. Pretty sure. Static array baseline dist equals new compute baselines. Okay, for int I equals 6. Oh. It's new int array of 31 int array. Okay. Then we say 6 less than baseline dis.length I plus plus, and we say baseline dis of I equals new grid of I dot get distances. Yeah. Okay. So we have now computed baselines. Now, everywhere I have baseline dist, I can instead say baseline dist of size. What? Did I not make that static? No, I did. Oh, I see. I guess I don't even need this anymore. I can just put it directly on the score function. I can say our baseline equals baseline dis of size. Then we can come up here. Okay. Great. Okay, that's our baseline dist. Somewhere I had a... Okay. Now that we have a baseline, we can just build up and we can say we have our cells. We initialized our cells to -1. And then we want to say I need all the cell values that are still allowed. Okay. Remaining equals enumerable dot range of 1 to cells dot length dot to list. Okay. So now conceptually it's for each unused cell, score each unused value. Only keep the highest values. Randomly select the highest. Randomly select one of the highest values. Rinse, repeat. Okay. For each unused cell, var best value equals long.minval. Okay. Var best value locations equals new list, and we want a cell number and a value. Cell int value. Okay. For int I equals 1, I less than, just do 0 here. I less than cells.length I plus plus. If cells I less greater than or equal to 0, then continue. Okay, that skips the unused cells. So now I need to try each of the unused values for each. Probably want this to be a hash set. I want that to be a hash set so that when I want to remove them later, I can remove them quickly instead of having to look them up. So now for each var value in remaining values, try placing it cells I equals value, score it, score equals get build up score, get build up dist, let's do dist equals get build up, we just call it build up dist of cells and I think we're going to come back to that in just a moment. And then we want to replace it cells equals -1. I don't actually need to do that. I can do this after. And then what we want is var score equals build up score of, let's just be explicit about this, dist A, dist B, okay. Build up score of dist and baseline dist of size, and then we say if score is greater than best score. Then we want to set best score equals score, and we want to say best value locations dot clear. Then we say if score equals best score, then best value locations dot add, and we want to add in the cell I and the value. Okay, then we say something like just to be very clear that that's what we need to do. Well, I guess no matter what, there's going to be something in there. So give me a random. Where's my random usage? Thread safe random. How about we just say thread safe random dot choose 1. We have a static class. Say static t choose 1 random 1 t this I enumerable. Now let's do something like, yeah, I enumerable t source. Actually, that's it. What are you complaining about? And then we say I don't really want it to be like that. This is looking in a list. Yeah, okay, let's just do list. And then we can say something like this. Selected index source dot count. Choice equals return choice. And this should give us a random 1. We're going to say thread safe random dot 1 choose. So now we can say best successors dot oh, I didn't make it public. Dot choose 1. Okay. And now, on the code that I'm writing, alright, so we did this for each unused cell, for each unused value. Only keep the highest values. That's what all this is. Randomly select one of the values. Okay. Var choice equals best value locations dot choose one. Okay, we're going to call this next. We're going to say cells, cells of I equals next dot value. I actually don't want to do this here. I want to try them all out. So I do need to say, okay, so we need to go like this. Cells of I equals -1. We set it back. Once we get done with all of them, then we say next.cell equals next.value. And then I need to do this. So now I need to do this over again. And I need to say best value locations dot clear. Okay. While remaining values dot count is greater than 0. Do all of this. This is getting excessively nested. Okay. Alright, so while there are any remaining values, so now I need to remove them from the value once it's selected. Remaining values dot remove of next dot value. Okay, now the only thing we need to do is calculate the build-up dist and then try it out. Oh, we're making improvement down here. I don't know if anybody just saw that. 148309. Where are we getting to? Nope, we still got a ways to go. Okay. This is good. So build-up dist needs to be a lot like the actual dist calculation, but for anything that is -1, it needs to treat it as the maximum value. So we're just going to take all of this and we're going to come up here. Basically what we're going to do is we're going to say we have not found an improvement for this thing. Okay. Get distances. I want build up score. And then I need this thing called build up dist. Static int array build up dist. And what does that take? The cells. Int array cells. Okay. And a size. Size. And this pair count is this. Int pair count. Okay. So exact same thing, only when the location is -1, when the location is -1, we can't actually do anything. If iloc equals -1, continue. If jloc equals -1, continue. I think that's it. If, oh, you know what? It's like this. It's like lookup. Okay, so what we need to do is say if cells I is less than 0, continue. So we don't want to have those in there. Okay, so we don't want to add those to the lookup. Instead, what we want to do is say if I is not in the lookup, okay, if not lookup dot contains key I, then continue. Oop, and J. Meaning that value is not in my array at all yet. Otherwise, you can go look up the location and start adding together the scores, setting the oh, yes. The distances. So my result is a bunch of zeros. and it's impossible to have a 0. So down here, ooh. Okay, so that's the dist, and then we say all right, what is this pair count? That's how we create the result. That's not what I want to do. I want to say baseline dist of size dot to array. That will create a copy. I no longer need this pair count. I no longer need this in. That will create a copy. Then we will just overwrite all of the ones we care about. When we go to here, we are doing baseline dist of size and dist. I think that's correct. Okay, so this is going to build it up. Let's take a look at this for a second. We have not used random restarts yet at all. We have not used random restarts. Okay. So we just say int restarts equals 0 while restarts is less than max, less than or equal to max random restarts. It's not really, well, I guess it is doing a random restart. Yeah. And we're going to say restarts plus equals 1. Oh, we just had another improvement. We're getting there. If we can get to 144,459, then we don't ever have to worry about 9 again. Okay. Let's try this on the one we're the worst at, which is going to be 30, and just see how it does. Let's just see how it does. Now let's do something like 16. We're pretty bad at 16, so that's the best score. Our score is 16,728. All right, yeah, we have quite a bit of an improvement to go on 16, so let's do 16. I want to choose a smaller one because I want it to go kind of fast so that we can do multiple of these. So now let's go up to the top and say baseline. We're going to do size equals 16. Going to let it do a bunch of restarts. But for the sake of argument, we're going to just do 1. So that we can test it out. Size And I think we're gonna step through it. Yep. Okay, how are we gonna step through it? Sure, you're complaining? Great. Which means you're just gonna get shut off. Okay, good. Not greedy, best next. What are we doing? We're doing build up of size and, 1 billion. Whatever. Okay. We go to build up. This is the remaining. This is creating a new cells. This is populating them. This is saying, give me all the remaining values. Oh. Then what we need to do is... Oh, yeah, we gotta actually score these or we're not gonna record the total result. Alright, so we're getting this funky score. And now what we need to do is get the real score. So now what we want to say is... Okay. We need to make a grid. Public grid int size int array cells. And we're going to call this of size, and then we're just going to replace it with, probably want to put this down here, and then we want to say something like cells equal cells. Okay, if cells.length not equal cells.length, throw new exception, wrong number of cells. Okay. So that will initialize it, and then it will populate the cells, and that will give us the ability to... And that will give us the ability to... then get the score, because we got to pass in a grid to get the score. Correct? Correct. Okay. So we're here, so now what we need to do is say var grid. Do I already have a grid? Equals new grid of size and cells. And then we want to say score size grid. And if that produces something that is better, then it will print it out. And I think for the most part, we kind of want to have an idea about what it's doing, so let's go ahead and print out a few. Let's do it like this. Score. Long total score equals 0. And we have the number of restarts already. And in fact, let's just call this a decimal, which is a huge value. And then we can say total score plus equals score. And then we can say if restarts mod, I don't know, 1,000 equals 0. Then we can say our average score equals total score divided by restarts. And we can say log average score and size. And let's go to our other one. And I don't want to run this over and over. I want to run this once, which is what we have it set up to do. For 16. And we know that our best for 16 is 16.7 million. I don't know why, but I really get the urge to walk through this the first time, so I think I'm just going to go ahead and do that. This is like a lack of trust in my own code right now. Okay. We created the cells. There are 256 because this is 15 by 15. We then have 256 times 255. There's going to be a lot of... Oh, well, I don't want to do this. That's going to be dumb. Let's not wait for that. Let's do... Let's just see if it gets here. Yep, should have. Okay, build up score. Let's get here. Long. What is my total? Dist. Okay. You know what I don't see here? Is any negative ones. I don't know if that was just like... Oh, no, okay. We copied it. The cells, that's what we care about. Okay, there are a bunch of negative ones here. Have we made any progress? Yep, there we go. We put a 101 there. So this is extraordinarily slow. Wow, that's all that time and that's as far as we got? Let's put a thing where it actually makes the choice. Hey, alright, we got there. Next. The cell is 136. And we're putting 124 in there, and we get rid of, now remaining values has 255. That doesn't make a lot of sense. Remaining values. Well, I see that 24 was removed because it's not right there. But that doesn't make a whole lot of sense. $120. We put 172. There's 255. Okay. Now I want to just let this go. This is going to take a hot minute. I really feel like this is way slower than it should be. I guess a good valuable thing to do here is like stop it and see how many. Okay, so there were quite a few in the best location. That's interesting. As this gets further along, $172, 24, 7. Okay. As this gets further along, it should speed up. In fact, let's stop it and let's have it print log $ of next dot cell next dot value. Just so we can actually see the output as it goes. Okay, 136 to 115. So that first one took what? 16 seconds. That second one took another 16. No, 14. And then this one took 12. And then that one took 11. So I have a feeling this is going to start speeding up a good amount. It'll also go a lot faster when we run it in... Oh, let me stop this. I just want to print out the average score right now, because this is not going fast. Maybe another thing we could do is just do this in production mode and see if it's faster. Oh, it shows the same thing. That's interesting. What was it previously? It cleared it out. I don't remember if that was the same, but I feel like it's not. Okay. That was 13. Alright, this is gonna go, and then we're gonna see the score that gets dumped out, and hopefully it's like way better. Like score-wise than what we have. So we're trying to get to 15.89 million, and we are at 16.72 million. I find it surprising that it would choose to put the same thing in the same location. Speed it up. Let's go. That doesn't feel right. That really doesn't feel right. By putting them in the same location, it is not changing the value at all. So how could it possibly think... Well, I guess it's related to all the ones that came before it. Yeah, I don't really know. Alright, we are going to sit here and watch this grind out for the, like, I don't know, 6 more minutes it's going to take it, 5 more minutes. Because if the value is good, then we can just speed this up. If the value is not good, then we're just wasting our time. In the meantime, why don't we go see? Ooh, nope, that's still the same one, right? 456. Yeah, that was a while ago. That was almost 30 minutes ago. It's difficult to know if this is making an improvement or not by watching the output. Speculatively, I'm going to say it's not going to improve it. But it'd be cool if it did. I guess one thing we can sort of do is make sure that it's not putting the same number in there twice. Okay. Still taking 9 seconds. Or 12. It's going. Yeah. How many has it done? Right, if we can... This is awful. Okay, to 14. Let's go here. That was 14. To 247. To 200. Okay, maybe we're getting close. Okay, it's done with 41 of them. There's 255. It's taking about... Well, we can just look at the time. 17:23. Oh man, this has been minutes. Jesus. Might be in for the long haul here. Why is this so slow? You're sort of... A thread exited with code 0. That probably isn't good. It's like they're taking variable amounts of time. It's really weird. If it turns out to be good, though, we are just gonna let this ride. What are we at? 205. Do do do. Okay. We're at 50. We are 1/5 of the way done, almost. All right, if we're averaging 10 seconds and we have 200 to go, we need 2,000 seconds. 2,000 divided by 60. 33 minutes? That's right at 2 o'clock. I guess we should do something else. Because it's going to be boring to watch this for that long. Okay. This still isn't making any improvements. Really what I care about here is just reaching that final goal of 144. 459. Like, as dumb as it is, this is a lot of what programming competitions are. They're just sitting around. I honestly, like, I want to restart that other one and run it in not debug mode just to see if that is, like, the primary problem. But I'm super reluctant. You know what? We haven't gotten halfway. If it speeds it up by half, we will definitely save ourselves some time. I'm gonna kill it. I feel awful. I feel awful. We're just gonna do this in debug. And, okay. Kill this. Alright. And we're going to say .NET run C release. Oh yeah, that's right. Yeah, that's right. Oh yeah, that's right. Oh. Oh. Is there a way to build .NET build to .NET run release to different folder? I don't want the working directory. .NET publish? Sure. .NET publish C release. Damn it. You know what? I'm going to kill the other one. We can turn that back on whenever we want. Fuck it. Fuck it. Okay. That was fast. Alright, this is way faster. Okay, at 256. Alright, see, now we're already. 200. 256 times 4 divided by 60. Maybe we'll do times 4.5. 250 times 4.5 equals divided by 60. All right, less than 20 minutes. I think this was worth it. I still think it's going to speed up near the end too, because what happens is it has so many fewer empty cells to check that it should be able to grind through them a lot faster. Come on, you can do it. What is this, 16? You can do it. So we started at 31.25. I should also print out how many remaining there are. Remaining values dot count. Have to check that on the next one. Come on. Okay, let's speculate why it is slow. You basically have an n squared you have an n squared, and then you have to do that another n squared times I mean, I can understand why it's slow. It's getting there. How long did we think this was going to take? Another... It's time to get a real idea here. All right, this is to 255. Here's how you select more at once. Oh shit, 231. Hey, alright, I can just go to the end like this. Alright, we've done 58 in about... in a little under 5 minutes. So that means there should be 4 minutes left? No, wait, no. Should be... They're not getting faster, they're getting slower. Okay, then we're also doing... We're doing an excessive amount of work. I don't need to copy. All I need to do is update. That's one way we can speed this up. Right? I know the cell index. Oh, that's kind of hard. Well, it's not going to be too much longer. You can appreciate why it might take a while for these things to finish. What would this problem be used for? Right? What would this problem be used for? You have a torus, and you want to lower the distances between things in a coordinated way. I don't know. I don't know. It doesn't make a whole lot of sense for me. I'm just curious to see what spits out. Trying each of the remaining values in each of the cells, is that valuable? Or does the only thing that really matters is how far those were away? No, I think it does kind of matter. All right, see how far we are now. Last I see is 116. Okay, we're at 91. Once we get to 128, we're halfway done. Now I'm just really crossing my fingers that this shows like a massive improvement on my score. Or I'm going to struggle with this when I go to bed tonight. Okay, let's think about the problem a little bit more. So this was... This is interesting in the sense of... I know you can hold AA still, and we've been taking advantage of that so far. I wonder if there are more things we can like guarantee to hold still. That will work. It's like if I did this on a ton of threads, another thing we could do here is we could randomly select them in a weighted format. Could say like, what is the score of them, and then use that as a weight and randomly select one of them, so that we're not always choosing the best one. Because best doesn't necessarily mean we're going to find the best solution. You know, the best at the intermediate steps doesn't necessarily mean we're going to find the best at the end of the solution. So if we weight them and then we randomly select amongst the weights, then we have a chance to land on solutions that are force you to go through non-optimal steps based on the metric that I have chosen along the way. Where were we? I think we gotta be halfway at this point. 170 was the last one. Here it is. Bloop bloop. Oh, not quite. Getting there. It's more fun when we sit together. What are other people doing today? Oh, there's a ton of people on.
Working on the PowerShell extension for VS Code, and then as typical of Microsoft, there was a big reorg, and then I got placed onto the PowerShell core team. So that's where I work now. I still work on the PowerShell extension for VS Code, among other things. I also.
Thanks for hanging out. Okay, so we need to hear required rotation minus.
Look at that.
Boomer 479.
Let's add score.
Oh, drugs, maybe, but that's my story. Someone's liquor vibe. Someone had some liquor. Did you have 10 Commandments by chance? It looks like 2 tablets. I had 2 tablets, but they were vitamin A and vitamin C. That was like 4 tablets. I'm 3 tablets. I can count. I remember that show. Yeah, what's the story? Oh my.
All right, we're halfway.
And so yeah, that's what happened. It was crazy. I almost said alcohol. Yep.
We might not be halfway on time, but we're halfway on selections.
Maybe they should have just labeled it fragile. This book is fragile. I mean, no one's gonna touch it. 3 tablets. I have plus an iPad tablet. Are there any AI chatbots on Twitch yet? Oh, I'm sure. I'm sure there are. I mean, we made some stuff with AI.
Unreal Engine 4 game dev.
I've made it, but I haven't recompiled yet. We might be able to do hot reload. I forgot about hot reload. I'm not allowed to do it. Well, it doesn't work at work. So, good day to you, mate. Nice to have you here.
Close to it like this is what I would imagine. And then maybe a third one that's just like totally unrelated. Sort of just whatever, right? And then I'm imagining this is a visualization I want to get to. So this is like views. You can't really see that. Just do a regular color. So views. This would be like add to cart for red, and blue would be what's our third activity type? Event type?
I don't know.
Profile updated. So this is probably what's
Let's go check out whatever else is going on.
this would be
Robo Master Finals. Win forms. Some video game.
item added to cart.
Open
I don't
source
know
fund.
What this would actually look like this or not, but I would expect that.
Unreal
in
Engine
reality,
4
I don't
game
have real
dev.
data, I have simulated data, but in reality,
Development of a game.
item viewed is going to be followed by
Getting the new user interface. Relaxing.
But you can kind of see I'm going for a lag there. And profile updated might not have any relation to items adding to the cart at all.
Blazer has state changed.
To give us our departure date. And we can pick. Then when we pick an item, it will collapse. And then we can go on to passengers, and then it will fly on passengers. And so, one thing it'll do is allow us to have scope into these drop-down boxes and only show what we need. Like it'll slip master cool
It goes faster when you're not watching it.
These are common UX patterns that
Where are we?
you see on, like Xbox and other games.
No.
So it's not far.
156. All right, 100 to go.
Users are gonna look at it and go, "What the heck is going on?" Let's see here. So I want to have something kind of like bold, like your departure date. So I don't so much want a button. Let's see if we can do those. So let's go over here. I want it to actually be an H2. I want it to be.
Does anybody here know Blazer?
Seconds.
Does set it to a warning.
There is a lot of C# going on today.
Which is a bit, like, I'm sure TBD, the only way you were able to tell that it was setting this to a warning was because of this comment, right?
Man, look at this nesting. I hate to
Oh, I didn't read your comment until
I hate to
oh my god.
harp on somebody's code style in the middle of a stream, but goodness. There's like 4 inches of
So yeah, so it does that.
it's crazy. That is a lot. Goodness me. So, if you're watching, the typical way to avoid this sort of like excessive nesting is to just take the negative, right? If you have something up here that's like if int apply equals then do all of this crap, the easy way to do it is to say if it not equals then just get out of here. Like this one right here is a perfect case. You have this else break. So instead you say if not this has authority then break, otherwise do whatever's underneath it, and you reduce your nesting significantly. Makes it a whole lot easier to parse and read.
Violated rules.
Because you could probably flatten this entire thing to only 2 nestings that try that for each, and that's I would not be surprised if that handled all of it. I wish it would scroll down a little bit so that I could see if there was anything underneath this. Because if there is no else condition, then doing the negative is almost a 100% better thing to do.
I think what should have been
Yeah, see how there's no case for the else down here. You just do the negative, and you can reduce all of the nesting of this, shift it back. Then you can do the negative of this, break on the negative of this, and now you have reduced all of this nesting back to the level of this first if up here. And since that if can also be negative, you can bring everything back to the level of the for loop. You can eliminate all of this nesting. This is so much more readable. It's also much more compact, like visually, vertically, I guess is the way to say that. It makes it a whole lot easier to read through your code. The only times when I feel like you can't really avoid it is when you have like nested loop, nested loop, nested loop, when you need to do something on top and below of each of your nested loops.
doesn't have authority to override
But other than that, you can almost always improve the visual layout, the visual look of it by just doing the negatives. Same with this one right here, right? If it's a stop, then just get out of here.
I think I understand what they're trying to do here. Hey, Panic, how's it going today?
I want to see some code. Whoa, he has a shirt. Whoa. Look at his shirt. Oh, you can't see it. Look at his shirt. Hey, Lizzie.
Okay, so we deserialize adjacent. Let's see what we need. We need a. Let's go define a block class.
Are we done? No, argument out of range. Fuck. Oi. Oh, look, they did get faster. Okay, well, that's important to know. We're going to try this on a smaller one. We're going to try this on a size 9. We're going to try this on a size 9. Should have done that in the first place. Should always verify that damn it. Okay, let's try that. And for the sake of argument, let's just do 0 so it'll actually quit. Okay, and let's debug it. Okay. Remaining 1. Choice. Selected index 0. What the hell? Let's go back. We're choosing 1. For some reason, there is nothing in here. Are all of the cells full? How many cells are there? There are 81. Is there any -1 here whatsoever? All of the cells are full. Interesting. Okay. I see a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So for some reason we're doing 1 additional. What's the remaining value? 41? Let's go see if 41 is in there. I'm looking for 41 or 81. There's the 81. Okay, so 81 is bad because it doesn't actually exist, right? You can't have an 81 in 81 cells. So why is this remaining value starting out with the incorrect number? That's what we want to know. Remaining values. Somehow there's 81. Is it inclusive? It must be inclusive. I guess we just do -1. Okay. 1 through 80. So 0 through 80 are the actual values. All right. Let's try this one more time. That's not a good score at all. That's an awful score. For a 9x9, right? Yikes. That is an awful score. Let's run it again and see if it improves. Let's do some random restarts of like, say 100. This ought to go pretty fast. I don't want to print those out anymore. Boy, that is bad. It does seem to be finding better scores the further we go, but that's just a randomness thing. That's not like built into it. Yeah, see, there it goes back up. I think that first one was, or those first two were particularly bad, but I don't think they get much better. So what if we get to the end of this and then we just run the seeker? I'm gonna try that. Let's get to the end here where we do this, but instead of scoring it like this, let's pass this grid on to here. I'm gonna say build up greedy. And then this is going to be an int and a grid. We're not going to do restarts. We're not going to randomize. We are going to score. We don't need to restart. Okay, so now at the end here, we want to say long and return best score. And now we want to say that's going to do the score. Okay, all right, let's try it like this now. So effectively what we're doing is like conceptually we're trying to get ourselves to a better starting point than just a random thing, and then we're trying to do the swaps. And that right there is a much better starting score. We're going to wait for this next one to come through. Okay. All right, well, just doesn't seem to be that good. I kind of want to know what the raw scores are coming out of there, not the average scores. So let's do that. Forget this total score. Just do our score equals score. And maybe let's do a bunch of these. So we're going to do this like parallel.for. Now size equals 9. Comment that. All right, we're going to run this on 8 threads. We're going to do 1,000,000 each, which is like never going to finish, but the point is not really to do that. I just want to see a local parameter named score. Greedy finish score. Okay. All right, we'll see a few of these pop out. Let us know what the score is. And then I think we're going to wrap this up so that I can get back to some other stuff that I need to do. I know today was a little boring watching numbers scroll on the screen, but I do really appreciate everybody stopping by today, so thank you very much. And I will be back tomorrow. We're going to do some more stuff on this. There we go. Here's our first batch of scores. There was one good one in there. Oh, getting close to the best that I've gotten so far. So overall, these are decent scores, whereas previously we were in the like... I don't actually know how far we were. Anyway. Okay, yeah, I will be back tomorrow at noon. Just like always, we do Wednesday, Thursday, Friday, and then on Mondays we try to get in an afternoon mentorship session. These aren't better. Alright, so we're just going to have to scrap this idea and come up with a better idea, because this is not a good idea. That's the long and short of it. That's just not a good idea. Okay. Okay. Yeah, so again, thanks everybody for coming to hang out. Let's find somebody to raid. We were just checking out a bunch of people. Let's see who is available right now. That's not what I wanted at all. Let's go to... Let's bump up Ed. Ed's doing some Blazor. If you're not familiar with Blazor, it's like a new web technology based on WebAssembly that makes it so that you can run .NET code or C#.NET directly in the browser, which is kind of cool. Let's go ahead. Ed. Char. There we go. All right, I will see everybody tomorrow. Thank you so much. And we're going to head over in just a second. Do, 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 do. All right, have a good one, everybody.